Hey sixth graders, today we are going to be talking about something called the mean absolute deviation. And in order to do this, we are going to be looking at some more dot plots and analyzing the data. So we're going to determine the distance from the mean. And to do that, it says this plot, or this dot plot shows 6 values. 1, 2, 3, 4, 5, 6. The mean of the values is 5, so they already told us that the mean was 5, but we could check by adding them all up and dividing by 6 since there's 6 dots. So 5, 10, 15, 18, 21, and then 9 more would be 30. So then if you have a total of 30 and you divide it by the 6 dots, yes, you get a mean of 5. Okay, so they told us the mean was 5. Now, the numbers below represent each dot's distance from the mean. So this is, maybe it's hard to see on the video, but this color right here is in blue, and there were 2 dots up here that were blue. And how far away from the mean were those dots? They were 2 numbers away from the mean. So they replaced those dots with the number 2. Now this green dot up here is the number 9, and how far away was that from the mean? Well, 5 all the way to 9 is 4 away, and so you'll notice that they replaced that green dot with the green number 4. And so when it says y is 5, the mean, we can write down kind of our math up here, because 30 divided by 6 equals 5. And the reason we use those numbers is because we added all of those values together to get 30, and we divided them by 6 because there were six dots there. And so our mean was 5. Then it says, what subtraction is used to calculate the distance from the mean to each blue dot? And you're just starting at the mean, which is 5, and you're taking away the value of the dot, which is 3. So 5 minus 3 is 2. That's why they have the 2's replacing those blue dots, because you took the mean and you subtracted the value of the dot that was there. So 5 minus 3 gives you 2, so they replace those dots with the number 2. Now, similarly, they're going to ask about the green one. What subtraction is used to calculate the distance from the mean to the green dot? And that would be 9 minus 5 equals 4, because they started with this 9, took away the mean, and the distance between them was 4. So now we're going to try that on our own. Calculate the mean of the dot plot below and label it. So let's start with that. So I have 3 plus 4 plus 6 plus 6 plus 7 plus 10. And what is that sum? Well, I know that 6 plus 6 is 12. If I put that together with 10, I get 22. And then 22 plus 7 more is 29. 29 plus 3 more is 32. And then 32 plus 4 more is 36. So if we have a total of 36 and 6 dots, there's 6 data points, we need to find our mean and take our sum divided by the number of data points, and we get a mean of 6. So first it told us, go ahead and label it. So right here, 6 is the mean. So I'm going to put an arrow and write down that 6 is the mean. And then it says, in the space at the right, write a number for each dot that represents the dot's distance from the mean. So just like what they did up here. So we're going to replace these dots. 6 is the mean. So how far away from the mean is 6? 0, because it is the mean. There's no distance from the mean in those 2 dots that are here. How far away is the number 7? Well, there's only 1 dot there, so we only need to write it 1 time. It's 1 away. How far away is the number 10 from the mean of 6? Well, 10 minus 6 is 4. So we're going to replace this dot with the number 4. Then, over on the left side of the mean, how far away is the number 4 from our mean of 6? Well, 6 minus 4 is 2. So on top of 4, I'm going to put a number 2. And then what about the number 3? How far away is 3 from the number 6? It's 3 away. So right now we have all of these numbers, and these represent each of these data points, they're dots. The numbers represent those dots' distance from the mean. We're going to use that in just a second. So Now we're going to actually learn how to calculate the mean absolute deviation. So each display below represents the same set of data. The display at the right shows a number in green to indicate each dot's distance from the mean, and use these displays for the next few problems. So you'll notice that every time there's a dot right here, they replace those dots with numbers, and those numbers, their values mean the distance from the mean or the average. Okay, so they gave us a clue here, and they said that the mean for these values is 4. They told us that. They didn't make us calculate it. So they're telling us that right here where the 4 is, that's the mean. So how far are they away? Well, the 2 is 2 away, because if you start at 4, it goes 1, 2, and there's 2 of those values there. That's why there's 2 2's. How far away is the 1 from the number 4? 1, 2, 3 jumps away. So we put a 3 there. How far away is 5 from the number 4? It's 1 number away from the mean. So we replace it with the number 1. And how far away is 10? It is 6 away from 4. So we replace that dot with a 6. So again, these numbers just represent how far away are the data points from the mean. So now find the sum of the distances from the mean. So we need to add all of these numbers that we just replaced the data points with. So we're going to add 3 plus 2 plus 2 plus 1 plus 6. 3 plus 2 is 5, 2 more, 7, 1 more, 8, 6 more, 14. So the sum is 14. Now divide that sum of the distances from the mean by the number of values. So how many were there? 1, 2, 3, 4, 5. So we're going to do 14 divided by 5. Now, I don't have 14 divided by 5 memorized, so I'm going to write it down. And I know I'm going to end up with a decimal here, so I might as well put one. And if there's a decimal in the house, we raise it to the roof. So 5 goes into 14 2 times. 2 times 5 is 10. Subtract, we get 4. Bring down our 0. 5 goes into 48 times. Exactly. 8 times 5 is 40. Subtract, and we get 0. So we just calculated the mean absolute deviation. This fancy word, which if you want to abbreviate it, is MAD, which is kind of funny. This is the mean absolute deviation, is 2.8. So what does the answer to exercise 6 represent? Like when we find the mean absolute deviation, we found it was 2.8. What is that actually telling us? Basically, it tells us the mean, which is the average distance that each data is from the mean. So it seems a little bit odd to say the mean twice, but you're finding the average distance that all of these dots are from the mean. Okay, so if the mean is 4, on average, how far away are all of your data points from that average, right? So you take, well, how far are all of them away? Here's how far they are. It's 3 away, it's 2 away, it's 2 away, it's 1 away, it's 6 away. On average, they are 2.8 values away from the average of the whole set. So it's kind of a funky little way to look at data, but that's what it is. It's finding the average distance that each value is from the mean. Okay, so now we're going to try it on our own. It says in a set of data, the mean absolute deviation is the mean or the average distance that each data value is from the mean. Hey, that's what we just wrote. The mean absolute deviation is a measure of the variability or the spread of the data in the set. In other words, it's telling you how far is your data spread out from your average data point. So we're going to follow the steps below to calculate the mean absolute deviation of the data set or the set of data that's shown right here. So it's going to kind of walk us through us. First, we need to find the mean of the data. So we need to add 1 plus 1 plus 3 plus 5 plus 9 plus another 9 plus 10 plus another 10. And what do we get when we add those together? Well, I know that 2 10s is 20, 2 9s is 18, so 20 plus 18 is 38. 2 more, because I see 1 and 1 would get me to 40, and then 5 plus 3 is 8. So if I put those together, I get 48. So my total of all of these, my sum is 48. And how many values are here? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So that'll work out evenly. So my sum is 48 divided by 8 different data points. So my mean is 6. So 6 is not one of my numbers, but it is my mean, which means on average, all these data points have the number 6. So find the distance each value is from the mean. So I want to know for the number 1, how far away is that from 6? I'm just going to put my answer to number 9. I think they want me to put details here. I'm just going to point. Say my answer is up here. How far away is 1 from the number 6? 5. How far away is 1 from the number 6? 5. How far away is 3 from the number 6? 3. How far away is 5 from the number 6? 1. How far away is 9 from the number 6? 3. How far away is 9 from the number 6? 3. How far away is 10 from the number 6? 4. And how far away is 10 from the number 6 again would be 4. So these are all the distances showing how far away are all these data points from that average or that mean of 6. Okay? Now write the sum of these distances. So we need to add together 5 plus 5 plus 3 plus 1 plus 3 plus 3 plus 4 plus 4. So I know that 5 and 5 is 10. 3 and 1 is 4. So 10 plus 4 is 14. 3 more is 17. 3 more is 20. 4 more is 24. And 4 more is 28. So the sum is 28. And now we can find the mean absolute deviation by dividing the sum by of the distances by the number of values. So how many of these were there? Well, we already figured out up here there were 8. So now we're going to take 28 divided by 8, since we're sharing 28 equally with all of those distances away from the mean. And 28 divided by 8 equals, I don't know, I don't have that one memorized, so I better calculate it right now. And I'm going to throw a decimal in there because I know that's not divisible by 8. If there's a decimal in the house, we raise it to the roof. 8 times 3 gets me to 24. Subtract and I get 4. Bring down my 0. It goes into 45 times. So 8 times 5 is 40 and we get 0. So now I have 3.5, which is my big fancy answer for my mean absolute deviation. So for this set of numbers, on average, how far away were all these numbers from the mean? They were on average 3.5 numbers away from the mean of 6. So which data set, this first one up here that had all these dots, or the one down here in the box, which one has data that's more spread out from the mean? Well, more spread out would mean that it's further away from the mean and not closer to the mean. So I would say that the second set of data, which is the one right here, not the one up here, I would say the second set is more spread out. And how do I know that? Because the mean absolute deviation is bigger or larger or greater. Up here it was 3.5. Or sorry, down here it was 3.5. Up here it was 2.8. So this on top, it means that in the first set, all the numbers on average are 2.8 values away from the mean. So they're closer to the mean. But on the bottom one down here, they're on average 3.5 values away from the mean. So they're more spread out. All right. So now we get to do some calculations with some real life statistics. Okay, so here's a couple basketball teams. We have Group A, which is 5 kids on a basketball team, and Group B, kids on the basketball team. So there's 2 groups of players on this team. There's 5 players in each group. So all these kids play on the same team. The tables at the right show the number of points the players have scored so far this season. Calculate the mean number of points scored by the players in each group. Okay, it doesn't say the mean absolute deviation. It just says the mean. So in order to do that, we must add all of these up on both sides to find their total. So I know that, let's do 5 plus 6 is 11, 8 more would be 19, 1 more would be 20, 2 plus 1 is 3, 3 more is 6, 6 more is 12, 2 more is 14, 4 more is 18. So we get 180 for that total. And how many players are there? 1, 2, 3, 4, 5 players. So now we get to take 180 and divide it by 5. I don't have that memorized, so I'll do it right here to find my mean. 5 goes into 18 3 times. 5 times 3 is 15. Subtract and we get 3. Bring down my 0. 5 goes into 36 times. And we end up with a mean of 36 for group A. Now group B, what is their total when we add up all their points? Well, 9 plus 1 is 10. 5 more is 15, 2 more is 17, 3 more is 20. 2 plus 2 is 4, another 4 is 8, 3 more is 11, 4 more is 15, and 3 more is 18. Hey, these guys have the same average. So group B also has a total of 180 points, but if you average it amongst the 5 players, we get the same answer. So they both have a mean of 36. Now we're going to calculate each player's distance from the mean number of points scored. We're going to write the distances in the table at the right. So how far away are Nick's points from the average of 36? Well, Nick scored 10. So how far away is 10 from 36? It's 26 away. How far away is Curtis's 31 from 36? Well, that's 5 away from 36. How far away is 68 from 36? That would be 32. How far away for Corey? We've got 26 away from 36. That's going to be, they're 10 away. And then for Hector, 45. How far away is that from 36? It's 9 away. All right, so now we're going to go to the other team. Or I guess it's the same team, just the other group of players on the team. Casey had 29. How far away is he from 36? He's 7 away. Pedro had 43. How far away is that from 36? Also 7. Zach had 32. How far away is that from 36? 4. Andre had 45. How far away is that from 36? It's 9 away. And then Tommy had 31. That's 5 away from 36. So here is how far away each of these kids or their players, here's how far away their points were from the average points scored by the team. So now we're going to calculate the mean absolute deviation of each group, which means we need to find the average of these numbers. So the mean absolute deviation, first you find the mean. Step 1 is find the mean. Step 2 is find the distance from how far away each of the numbers are from the mean. And then step 3 is average all those numbers. So now we have to average all of these, which means I need to add them up and then divide by 5 since there's 5 in each group. So I'm going to add these up. 6 plus 5 is 11. 9 more is 20. 2 more is 22. 2 plus 2 is 4. 1 more is 5. 3 more is 8. So we get 82. But then I need to do 82 divided by 5 because there's 5 kids. So 82 divided by 5. I'm going to put a 0 up here, a decimal, because I know 82 is not divisible by 5. So if there's a decimal in the house, you raise it to the roof. 5 goes into 8 one time. 1 times 5 is 5. Subtract, we get 3. Bring down my 2. 5 goes into 32 6 times. 6 times 5 is 30. Subtract and we get 2. Bring down my 0. 5 goes into 24 times. And we can 0 that thing out. We get 16.4 is the mean absolute deviation for group A. Now for group B, we can add all of these up. And I know 7 plus 7 is 14. If I add 9 more to that, I get 23. 23 plus 4 more is 27. And then 27 plus 5 more is 32. So if I take 32 and divide that by the 5 players, we'll find the mean absolute deviation for group B. So we're going to do the same thing here with adding a decimal and a 0. 5 goes into 32 6 times. 6 times 5 is 30. Subtract, we get 2. Bring down the 0. 5 goes into 20 4 times. 4 times 5 is 20. And subtract, and we get 0. So the mean absolute deviation for group B is 6.4. So what does your calculation suggest? Well, for group A, they had a mean absolute deviation of 16.4, and for group B, they had a mean absolute deviation of 6.4. So what does this tell us? I think that it tells us that both groups, their mean is exactly the same. Both groups on a typical game are going to score about 36 points. But I would say that the scoring for group B is closer to the mean than group A. Okay, that means it's less spread out. So like for group B, how far away they were from how much the average scoring was, what they got for their scores is closer to the average score. So all these kids score closer to the average compared to Group A. Group A, they're more likely to have kids that score way more than the average or way less than the average. Whereas Group B, they're kind of more consistent. They're closer to the average. Okay, so for the next question, which player in each group has the greatest deviation from the mean? In other words, which player is furthest away from the average? Well, we can look at the original scores if we want, or we already did the work down here. So I would say that the highest distance from the mean, so for Group A, that would be Nick. Oh no, not Nick, I was thinking 26. No, 32 is more than 26. So Raul, because he has 32 points away from that group average, which is 36, okay? And then for Group B, which is the highest one, it's Andre, because he has 9. And so he is furthest away from the mean as well. So which group has the greatest deviation? Which kid is furthest away from the average? It would be Raul and Andre, because Raul is 32 points away from the average and Andre is 9 points away from the average. So what does the greatest deviation from the mean suggest about the two players that we just said for Raul and Andre? Well, I think it would be pretty safe to say that for these kids, we can say that both of them are greater than the mean. So both deviations, I don't know if I want to call it a deviation. We could just say both, maybe it is, we could just say it a deviation. What I mean when I say deviation is the distance from the mean. That's the deviation. So we can say both deviations for Raul and Andre are greater than the mean. So we can say, are more likely to score the greatest number of points in a game. Right? So in both these groups, these kids were Raul and Andre both were farthest away from the mean, and so they are more likely in a game to score more points than anybody else. Okay, so we have one more page to finish up this activity today. And what we get to do here is a puzzle penguin problem. It says, "Dear math students, on the last day of school, the students in a 6th grade class were asked how many days they were absent that year. The table shows the data that were collected," right? So we have the boys, this is how many days they were absent, and the girls, this is how many days they were absent. I calculated the mean absolute deviation, so he calculated the MAD, for each set of data. I concluded that the data for the girls showed more variability than the data for the boys, which means that if you have more variability, that would be a higher MAD for the girls. That's what he thinks, okay? Because the higher the deviation for the mean absolute deviation, the higher your number, the more spread out your data is, the more variable and varied is your data. So I was told my conclusion was wrong. Can you tell me why? Okay, so they gave us a way to kind of get a little bit of help here, and they set up another table for us to use. So instead of just the number of days absent for the boys, we're going to first calculate what is the average of all of these. So what we can calculate first is how many on average days were the boys gone. So we're going to add all of these up. So I have 9 plus 1 is 10. 0, it's still 10. 0, it's still 10. 0, it's still 10. 0, it's still 10. 3 more is 13. 2 more is 15. 5 more is 20. 8 more is 28. Okay, so we have 28. And how many kids are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 28 divided by 10, because our sum was 28 and there's 10 boys, equals 2.8. So the average number of days absent for the boys was 2.8. Now for the girls, let's find theirs. So we have, I'm going to do my zeros because they don't really matter. 1 plus 3 is 4. Another 4 is 8. 2 more is 10. 5 more is 15. 3 more is 18. I'm going to put my 2 halves together to get 19. And then 3 more is 22. And then 4 more is 26. So divided by 10, because there's 10 girls in the class as well. And their average, or their mean, is 2.6. So on average, the boys were gone a little bit more than the girls. They were gone 2.8 days, and the girls were gone 2.6 days per kid. But that's not what they were asking. Puzzle Penguin said we are finding not the mean, but the mean absolute deviation. So now we need to figure out how far are all these boys and girls from their averages. Okay, so the first boy had 2 absences, and the average was 2.8. So how far away is he from the average? Well, he's only 0.8 away from the average. Maybe I'll put a 0.8 to make it look more clean. 0, how far is that from 2.8? Well, exactly 2.8. 8, how far away is that from 2.8? 5.2. Okay, what about 5? How far away is that from 2.8? It's 2.2 away. 0, oh, that's another 2.8 is exactly, that's the number we want. For 3, that's only 0.2 away. 0, we can do another 2.8. 9, ooh, how far away is 9 from 2.8? It's 6.2 away. And then another 0, which means another 2.8. And then finally a 1. How far away is 1 from 2.8? It is 1.8 away. Now what about all of the girls? How far away were the girls? What is their distance from the mean? So the first girl was gone 0 days. So how far away is she from 2.6? She's 2.6 days away from the average. The second girl was gone 3.5 days. How far away is that from 2.6. It's just 0.9 above that. The third girl was gone for 1 day. What is 1 day away from 2.6? Maybe 1.6. The next girl was gone 3 days, so that would be a difference of 0.4. The next girl was gone 4 days, which would be a difference of 1.4. The next girl was gone 0 days, so she was exactly 2.6 off of the average. The next girl was gone 4.5 days, which would be 1.9. And then we have 3 again. I feel like we already saw 3. Yeah, it's 0.4 because 3 is 0.4 more than 2.6. 5, we had a girl gone 5 days. How far away is that from 2.6? That's 2.4 away. And then 2, how far away is 2 from 2.6? It's just 0.6 away. Okay, so we did all the hard work of calculating how far away is each individual data point from its mean. Now we have to find the average or the mean of all these data points, and that's going to be our MAD, or our mean absolute deviation. So our next step is to add all these numbers up. So I'm going to add all the boys up first, and then I can add up all the girls second. All right. I see lots of 8s and 2s here. So I'm going to use a different color. I'm going to combine as many as I can. So 8 plus 2 is 10. Another 8 plus 2 is 20. 8 plus 2, that would be another 10, which is 30. Another 8 plus 2 is 40. And then 40 plus 8 plus 8 is 16. So 40 plus 16 is 56. And now I get to add all of these. 5 plus 0 is just 5. 2 more is 7, 5 more is 12, 2 more is 14, 2 more is 16, 0 more is still 16, 2 more is 18, 6 more is 24, 2 more is 26, and 1 more is 27. So this is 27.6. And then what about the girls? So the girls, we're going to add them up, and we've got lots of 6s and 9s and 4s. Well, I'm going to put my 6 and my 4s together because that equals 10. So 6 plus 4 is 10, another 6 plus 4 is 20, another 6 plus 4 is 30, another 6 plus 4 is 40. Now I have, so 40 plus a 9 and a 9. Well, 9 and 9 is 18, so 40 plus 18 is 58. Now we have 5 plus 2 more is 7, 1 more is 8, 1 more is 9, 2 more is 11, 1 more is 12, and 2 more is 14. So we get 14.8 for the girls. So we still have to divide these by the number of students in each class, and it's going to be the same as when we found the mean. There's 10 boys and 10 girls. So if we want to finish calculating the MAD, we have to do the boys, which is 27.6 was their total sum of their distances from the mean. We're going to divide that by 10 to find the mean, or the average. And if you're dividing by 10, you just have to move the decimal point to the left, which is 2.76 for the boys' MAD, for the boys' mean average deviation. And then the girls, they had 14.8. And we're going to divide that by 10 because they also had 10 girls in their group. Move our decimal place 1 point to the left, and we get 1.48 is the MAD for the girls. That was a lot of work, but what we just found out is the boys had a mean absolute deviation of 2.76, The girls had a mean absolute deviation of 1.48. What we said when we started this problem is that Puzzle Penguin said the data for the girls showed more variability. That means that they had a higher MAD. They do not, Puzzle Penguin. The girls have a lower MAD, which means the boys actually show so the boys actually show more variability than the girls because their mean absolute deviation, or their MAD, is higher. So that's why Puzzle Penguin is wrong. He said that the girls have more variability and a higher MAD, but it was actually the boys that had a higher variability and a higher MAD. All right, so that's kind of a different way to analyze data, but that is how you find the mean absolute deviation. I hope it doesn't make you too mad. Haha.